This speaker series. It's part of the TOCS family of talks. It's been focusing on service systems and services in general. It's a pleasure to introduce Professor Willem-Jan from Tilburg University. He's actually a full professor. He's also a director of the European Research Institute on Service Science. He's been very active in web services, cloud systems, looking at business process services over the last 5 or 10 years. He's also been quite active in promoting both a master's program in services in Europe and also a PhD program where they have master students traveling across 4 or 5 universities across multiple semesters to get their degrees. So it's one of the unique kind of programs they have in Europe. And they're also beginning to interact with universities in America to have students come and spend some time here. So it's a highly valuable way of doing things. So it's a pleasure to have him here to talk about the cloud and blueprint in the cloud. Thanks once again for coming.
Okay, thank you very much, Ramesh, for your introduction. Thank you very much, Martin Gris, for hosting me here and for allowing me to give this presentation today. And as you can see on the first slide, my presentation today will be on business process as a service, making use of a new technology that we are currently developing in the context of a European project, and which we refer to as blueprinting. So I've prepared quite a lot of material. I'm not sure if I can cover everything today, but what I will do first is I will firstly briefly introduce myself, telling you a little bit more about my background or where I'm from, and also I will spend a couple of words on IMSI, which is this master program that Ramesh alluded to before. After that, I will delve deeper into, let's say, the subject matter of today. And in particular, what I will do is I will focus on the state of the art in enterprise cloud computing, and then I will take you through a couple of the big challenges that we see, at least from a European vantage point. And after that, I really would like to delve deeper with you into a syndicated multi-channel cloud delivery model that we are currently developing as a basis for the blueprinting approach, which will allow, at the end of the day, the combination of various SaaS solutions into, let's say, end-to-end applications. So this may sound like a little bit of abracadabra to you right now, but nevertheless, I hope that toward the end of today's presentations, you have a little bit better, let's say, insight in the things we are currently developing. So by no means the presentation is presenting final results. So what I decided to do is today I decided to take you through a couple of the ongoing research issues that we see in Europe, and in particular that we work on in Tilburg at the European Research Institute in Service Science, ERIS, in other words. So one of the first questions I normally get is, where is Tilburg? Where's the Netherlands? So just for, let's say, to refresh your minds a little bit, so the Netherlands is a relatively small country, Western Europe. We have England, we have Germany, Belgium as our direct neighbors. And in particular, Tilburg is a city. It's not that well known by itself, but the university is really, it's top ranked, mainly in business and management. And Tilburg is sitting in between Rotterdam, I guess, and Eindhoven. And this is the place where ERIS is hosted. ERIS is a European Research Institute. It means that we have a lot of collaborations ongoing with other European universities and institutes. For example, we work with universities and institutes in Italy, Germany, Greece, Belgium, England, and so on and so forth. And even we go beyond the borders of Europe. We also have quite intense research relations, for example, with Tsinghua University in China, with University of New South Wales, Australia. And also what we're trying to do is to set up collaboration here with CMU, and we have some ongoing collaborations also with UC Berkeley. So ERIS, what is it all about? It's an institute. It's conducting research, fundamental research, but also more applied research. And what we try to do is we try to solve business problems from a multidisciplinary vantage point. So we're not a pure computer science group, although we depart from computer science. But what we try to do is we try to, let's say, take into account methods and techniques from neighboring disciplines like business and management. We are a European Research Institute. It not only means we're working together with European institutes, universities, but we get a large part of our funding from the EU. So currently we are involved in roughly 5 European projects, which are all revolving around services science and service engineering. And most of the recent projects, of course, include a cloud dimension. We are the founders of the International Conference on Service-Oriented Computing, which takes place, which rotates between Europe and countries outside Europe. It was also organized here in the US a couple of times. We are the editors of a book series of MIT Press. It's a series on cooperative information systems, and we also have a series at Springer Verlag focusing on service science in particular. In our group, we are quite active. We are also authoring books which have been published at publishers like John Wesley, MIT Press, and Prentice Hall, just to give you some idea of the things that we're doing. So it's not only that we are conducting research in the context of European projects, but also we try to consolidate our findings and our work in monographs, for example. Research is the main emphasis of ARIS. We are also involved, though, in education. In particular, we are the founders and program coordinator of the prestigious EU Erasmus Mundus joint degree program, which is delivered by 3 European universities. It's the University of Tilburg, University in Stuttgart, the group led by Frank Lehmann, which some of you may know, and also a university in Crete, which is led by Christos Nicolaou, who will be one of the speakers, I believe, later on next year. Besides that, we are also the joint founders of a very successful summer school on service science and service engineering, which takes place every year. I think this year or next year it will be around the 10th time. It takes place in Crete. I don't want to spend too much time by explaining to you my background and telling you a little bit more about ARIS. And instead, I would like to spend some words on this Erasmus Mundus joint program on service science and service engineering. It's very prestigious. It's sponsored by the EU, which means that the EU provides scholarships. Scholarships to students from Europe and outside Europe. And these are quite generous scholarships. So they are enough for the students to pay for the daily living, of course, also tuition fees and also mobility, because these students are traveling from one place to the other. So in particular, we have organized this joint degree program as a 2-year program. It starts off for 1 semester, 6 months in Germany, Stuttgart. Then the students move physically to Crete, Greece. And then for the 3rd semester, they go to Tilburg University. And what we do in this program is we teach service engineering from various perspectives: computer science, information systems, and a business perspective. We work together with.
Question there.
Okay, this question.
There.
Okay, please.
Which group in Carnegie Mellon do you work with? Oh.
Yeah, it's Martin. Yeah, Chris. Yes. So thanks for the question. So we work together with associated members, industry members, and also academic. So we work very closely together with companies like Daimler, Software AG, PricewaterhouseCoopers, IBM, Germany in this case, and Forthnet, which is a Greek telecom provider. And of course, we also have some academic partners which are listed and which you have probably already read yourself. So what's the idea behind these academic partners? And I thought it would be particularly interesting for you. I'll speak here at CMU. In particular, the EU provides not only scholarships for students, but also for staff. And in particular, what the EU does do is they provide scholarships, as they call them, and which allow staff from our associated academic members to come over to visit us in Tilburg, or in Stuttgart, or in Crete for a period of 2 weeks and a maximum stay of 3 months. And you get a flat fee of 1,200 euros a week. And we are actively looking for scholars, for staff who would be interested to come over, to be involved a little bit maybe in teaching and also in research. So herewith I invite you all, if you're interested, please just let me know, drop me an email. And I guess there are big chances that we could, let's say, grant these scholarships through the EU. So one of the possibilities, okay, sure.
So would the idea be that students would rotate here for part of their degree?
Okay, that's a good question. So I was just talking about the staff. There is, of course, also the student mobility. So the students, they have 4 semesters. The first one was in Germany, second in Greece, third in Tilburg, and thereafter they can go out. They can go out of the EU, and they can do part of the internship, for example, in other places. And in particular, these will be the the places or internships provided by the associated members outside the EU. So this is in Australia, University of New South Wales. It's in China, Tsinghua University, and here in the US, we'd also be very pleased if students could do an internship here and work on research, small research projects. That would be the idea. So one of the, I guess, interesting things that one could take into consideration is to start lecturing at the summer school. It will be organized next year at the beginning of the summer. It's a very nice period of the year. And in particular, it will take place from the 2nd until the 7th of July. It will be a special event, given the fact that this will be the first time that we will have graduates. There will be the graduation ceremony of the first IMSI cohort. So I guess that one could consider, let's say, combining the scholarship with participation in the summer school. So here again, I invite you to consider this possibility. In case you would like to have some more information on the program, I mean, there's much more to tell about it, please visit our website, which I've marked here in red. Okay.
So also I should mention that this program is different than the NSF-new program that also is there, where you can have students from here go there. This is more students coming from Europe to America that spend like one semester. And they're funded by the program. It's like a scholarship, right? And how many students do you have right now?
So it's a relatively small group. It's roughly 15 to 20 students. So if you want to know more, so it works as follows. So normally we get a lot of applications, between 50 and 100 applications. Worldwide, we select the best students from all over the world. So it's a quite prestigious, I guess, program in that respect. And the students get very generous funding, I should say.
And how many people do you have in your staff?
At Public University, okay. Within ARIS, we work roughly with 15 staff members. It's full professors, and the rest is PhD students and postdocs. Okay. So let's move on now to the main topic of today, which is, of course, on blueprinting in the context of the cloud. So first of all, what I want to do is I want to, I guess, provide you with my mindset on the current status in enterprise cloud computing and focus on some of the key challenges that we see in that field. And in particular, those key challenges, they did arise from our, let's say, collaborations with other EU partners and also industry. So cloud enterprise computing is booming. I guess this is a worldwide phenomenon. I mean, if you look at the market of SAS services, it started from a market of roughly 8 billion. It did rise up to 9.2 billion in 2010, and it is expected that SAS revenue will hit around 11 billion for this year. Of course, if you look at the usage of clouds by small and medium enterprises, you see that roughly 74% of the small and medium enterprises, they plan to use a cloud service. And this is a rise of 12% in comparison to last year. And if you look at how many of them would like to use paid cloud services, it's roughly 39%, which is also a dramatic increase of about 10%. So SAS adoption is booming. And it's driving, it is accelerating the adoption of other cloud models as well. So in particular, what SAS adoption is doing, it is driving also IaaS adoption, PaaS adoption, and a third model of cloud computing, which has emerged since recently, which is called business process as a service. And I will concentrate in the remainder of my talk on the combination of business process as a service with software as a service. But you can see here yourself on the chart that SAS adoption has will probably rise from 37% up to 54% in the coming years. So this is something which will stay and will have a dramatic impact not only at the computing infrastructures at companies, but also it will have a dramatic impact on the way in which they will conduct business and start collaborating with each other. So if you look at the SAS market, of course, it's a very broad spectrum that you have. And I found one quite interesting article that surveys the SAS market. It's quite recent. It's published in July of this year. And there you could see that roughly 1/3 of the SAS market, it's roughly here estimated as 3.8 billion, it continues to be in CRM. So it is the sales forces of this world. Another third of the SAS market is focusing on content, communications, and collaboration solutions. And the remaining third of the market concentrates on solutions like ERP kind of packages. Just to give you some idea of the types of SAS solutions which are around. So in a nutshell, cloud computing, in our viewpoint, is transformational. The adoption clearly is quickly accelerating, and we can see this happening in Europe, not only at the level of the large enterprises, but also at the level of small and medium enterprises. So we've got a very rich ecosystem of SMEs, which is emerging. It's increasingly used not only to support, let's say, secondary processes, but these days also for more primary business operations. And it really helps us to come up with new ways of doing business. You can do business these days from a little cafe sitting somewhere and developing a new business solution, and which was previously unthinkable. And clearly, cloud computing is not only about IT infrastructure, but it is really about the complete enterprise in its own right. Cloud delivery models have emerged. I think that by now there is some consensus about the following three ones: the SAS delivery model, the PaaS delivery model, and IaaS delivery model. I don't think I need to spend too much time on this slide right here, because I think most of you do already have a background on cloud computing. But nevertheless, I gave a couple of examples of each and every cloud delivery model in this slide. At the end of the day, cloud computing is all about virtualization of resources. And these can be low-level infrastructural resources, but likewise could also be resources at the application level. And in ARIS, in our research group, we are mainly interested in, let's say, the higher levels of abstraction. So we are concentrating at the SaaS level and the PPAS level, as you will see later on in my talk. If you look at current research in cloud computing, you see that there is a substantive emphasis on the lower level technological trajectories. So for example, cloud scalability is a very hot topic, and it has been researched in the context of horizontal scaling, for example, and vertical scaling, where it means that in horizontal scaling, it means that a new server is replicated, and there's use of load balancers. In the case of vertical scaling, it means that you can change resources on the fly. So a lot of research has been focusing on the IaaS level and also the PaaS level, while the, let's say, cloud application development is largely terra incognita. There's still a lot of work which needs to be done in that field. And in particular, we are concentrating on that. So if you look at the current solutions, we believe that they suffer from some problems, some impediments. And in particular, from a client's perspective, in fact, an SAS solution is very monolithic. It's delivered as one monolith. And as a end user, for example, the IaaS or PaaS solutions on which the SAS is built are opaque. You don't know about them. And at the same time, it's also very hard to extend or modify the functionality which is captured in an SAS solution, at least without the help of the actual cloud service provider. So also the SAS model, it assumes, let's say, a Macy's approach, one-size-fits-all approach. So one solution will fit the needs of all, and which we believe is not correct. So there are some more problems with current SAS solutions. So, and in particular, it's quite difficult to compose existing SAS solutions into, let's say, composite solutions. And you need those composite solutions many times in order to be able to support end-to-end processes, probably between various companies. At the same time, it's also very difficult to reconfigure SAS solutions. For example, it's almost impossible to make any changes to an SAS to deal with changes in demand, in peak demand. For example, remember yesterday, Cyber Monday, if you would have an SAS solution, You don't have a control as a client on the lower levels, on the IaaS level and the PaaS level, right? So it's up to the discretion of the SAS provider in order to provide you something which meets, I guess, the contractual obligations that have been stipulated before. Nevertheless, these are the big challenges that we see. It's not only, by the way, challenges that we see in ARIS, Topic University, but these are challenges which have been recognized by the EU, and we are working on those challenges in various EU projects. At the first slide, I mentioned one acronym. It was Forecast. This is a European-sponsored project involving not only research institutes and universities, but also telco providers like Telefonica in Spain and Sony and Ericsson. And they also see these problems, and we are actively working with them on solutions. So what we want to give to the developers of PPAS applications, we want to allow these developers to pick and choose, so to selectively pick and choose those SAS solutions that fit best to their needs. So they can have various options from which they can choose and which they can use to, let's say, implement their end-to-end business process, which is depicted here at the top layer of the slide. So this is the PPS level I'm talking about. And at the same time, we want them to be able to choose the most fitting, the most optimal PaaS solution that fits the needs of the SAS best, right? So what we want to do, in other words, we want to slice the SAS monolith both vertically and horizontally, okay? So both vertically into, let's say, finer-grained SAS solutions, which are loosely coupled, which will allow for better, for example, elasticity and more flexibility, more agility. And also we want to, let's say, slice SAS solutions horizontally. So we slice application level functionality from platform level functionality and infrastructure level functionality. And this will allow a cloud developer to select the best solution at each level of this, let's say, multi-channel and syndicated cloud delivery model. So in other words, what we're trying to do is we're trying to inject the best practices, the things which work out fine in service-oriented computing, into cloud computing. This is what we're trying to do. And
example do you have here on 3 layers?
Pardon me?
What examples do you have?
Yeah, so that's the next slide. So in particular, we are focusing on business processes, for example, order management, which is an end-to-end business process, which could make use of various SAS components, for example, for purchase order management, for scheduling, and for shipment. And each SAS solution on its turn could make use of IaaS solutions, for example, repository systems providing product catalogs or sales order information on delivery data. So at the end of the day, at each level of abstraction, you want to choose the most fitting cloud solution sitting underneath the cloud service in question. So we don't only take into account, let's say, the functional characteristics and behavior of cloud services, but we also take into account extra functional properties in QoS. This sounds still a little bit abstract, I realize that, but later on, when I will introduce the blueprints, I hope things get a little bit more clear to you. So blueprinting. If you look at the current state of managing and deploying cloud solutions, you see 2 prevalent solutions. First of all, one can make use of templates, which have been, let's say, defined by a distributed management task force. And you also have model-based approaches for, let's say, developing and deploying cloud solutions. Both approaches, by the way, tend to focus at the lower levels of the cloud stack. In other words, they focus at the IaaS layer and the PaaS layer. So, for example, the templates, they not only describe the functional interfaces, but also management interfaces, which help you to, let's say, provision and manage the usage of cloud services. And in particular, what DMTF does do is it provides you with templates which are abstract descriptions of the functionality of cloud services at either level of abstraction. Okay, and it provides these templates at the various phases of the life cycle of a cloud service, starting at their, let's say, definition and creation, and refining them into specific cloud offerings, which can be, let's say, contracted, and at the end of the day, instantiated and deployed. Okay, so one starts with a very abstract description of a cloud service, which is defined in the abstract, so completely, let's say, regardless of the underpinning implementation. And one gradually refines these templates into instances which are running. And one gradually adds more information. For example, one adds information about IP address ranges, storage requirements, and the machines which are necessary in order to deploy a specific cloud offering. So there's a second approach, and this second approach builds forward on model-driven architectures. And the idea here is that you are able to treat virtual images as building blocks. Okay, so one can define various building blocks of a cloud solution. For example, one building block for HTTP traffic, one building block for a local receiver, one Ruby on Rails node, and one MySQL database, which are here depicted as these squares in the slide. And they can be connected through connectors. And of course, what you can also do is you can define the negotiation protocols between these virtual images. You can do this in the abstract. So the basic idea would be that any, let's say, user, not IT expert, would be able to select appropriate building blocks and connect them together, after which one could generate the solution, the cloud solution, and deploy it on various, let's say, solutions like Amazon Web Services or GoGrid. Both approaches are quite promising, and they have some very, I guess, interesting elements. But once again, they tend to focus at the lower level of the cloud stack. So what we try to do is we try to come up with a novel approach that takes some of the successful elements of the DMTF templates and the model-driven architecture into something new, which we call cloud blueprinting. I mean, vendor lock-in is perceived as one of the major drawbacks of cloud computing. And some of the latest studies, they reveal that vendor lock-in and immature cloud interoperability standards surpass even security concerns as the biggest objection for moving to the cloud. So it means that at this moment, in case you are a client of an SAS solution, you're really, it's really up to the provider of the cloud solution to help you with extensions or customizations of a particular SAS solution, or even connecting it to another SAS solution. And what you would like to do, as I have told before, is you would like to slice this, the SAS both horizontally and vertically in order to allow a cloud engineer to dynamically mix and match cloud components. So in our viewpoint, you need a couple of elements which are part of this cloud blueprinting approach I've been talking about. So in particular, we start with a description, an abstract description of the functionality and QoS characteristics of a cloud at any layer of abstraction. Doesn't matter. And this is done in a language which is the blueprint definition language. This is a language which we have been developing together with telco companies like Telefonica and Sony Ericsson. Next to that, you need to be able to define constraints. So what we have done is we came up with a constraint language, the blueprint, the BCL, the blueprint constraint language, second bullet point here. And it will allow you to define things like policies, performance requirements, and capacity requirements. And last but not least, we are working on a BML, which is a blueprint manipulation language, which provides a set of operators for manipulating, comparing, querying, and composing blueprints. So at the end of the day, we are going to give the cloud engineers a toolkit which will help them to describe cloud services in the abstract, to select cloud services at any level of abstraction, and to compose cloud services, both vertically, combining SAS solutions with PaaS and IaaS solutions, as well as horizontally, integrating, for example, various SaaS solutions. This is what we are working on now in various European projects. And what we have done is we have defined something which we have called a blueprint lifecycle, where the basic idea is that we have a marketplace repository where we can store the various blueprint definitions. And at the end of the day, we are going to develop, we are in the process of developing, for example, things like a query engine and also a manipulation language, which will allow to find the most appropriate cloud services, combine them, and at the end of the day, deploy them and test them and configure them. Of course, we're not doing it all. This is a huge grand scheme. It's a vision more than a reality, that's for sure. At Tilburg University, what we have been doing is we have been mainly concentrating on the specification languages, the cloud specification languages, and the manipulation languages. It's not that new, by the way. I mean, we have seen definition languages before, like in web services, but what we are doing, of course, is we are extending these languages to cater them for the cloud. This is basically what we're doing. Our manipulation language is it's grounded on model management, which some of you may know. It's, let's say, a algebraic theory from databases. So we're building our operators on top of already existing work in that field. So these blueprints, you may think this is some kind of magic. What do they look like? So what I'm going to do next is I'm going to very quickly give you an overview of the current state of affairs with regard to the development of the blueprints and the manipulation language. So in particular, what we do in the blueprints is we define the functional characteristics like you would do in WSDL, specifying things like service types, the messages, the interfaces, and operations. But next to that, we're also defining something which we call performance-oriented service capabilities. In other words, what we would like to do is we want to capture the KPIs which may be associated to the services in terms of the ranges of service availability, latency, and bandwidth. At the same time, we want to be able to define resource utilization. So in other words, we want to describe the physical infrastructure and the actual resources which are required to run the services at any level of the cloud stack. Policies, they are orthogonal, they are pervasive in our approach. They prescribe and they constrain any aspect of a business agreement that is needed to use the service. So in other words, what we also, of course, are going to take into account is the SLAs, which are going to be stipulated and agreed upon between a cloud service provider and the client of such a cloud service. So this is basically how the blueprint will be composed. And at the end of the day, what we did do is we came up with some specifications. What I've done for this presentation, I simplified it, so I threw away all the XML tags, or at least most of them, just to give you an idea how such a cloud service description would look like. So in this case, it's a blueprint, which is defined at the level of an SAS. It's used for vehicle management. And in particular, what it does do, it manages the status and location of vehicles. So as you can see here yourself, what we really do is we describe the SAS functionality in the abstract. Also focusing on things like the resources which are needed. For example, a JEE application server and a MySQL database, let's say, platform. And at the same time, we also define constraints. Constraints which can be derived from the policies in terms of, for example, the SLA profile, the price per month that you're willing to pay, but also QoS, let's say, constraints, and constraints at the level of security and compliance.
I have a question. So you mentioned you built on the MDA approach. So are these UML stereotypes? Is that what I'm seeing?
Yeah, that's what you're seeing. That's correct. So at the end of the day, we want to come up with a semi-automatic approach to refine these definitions into running instances.
And then BCL will be an extension of OCL? Or
Yes, yes, indeed, it will be based on OCL. Also some other languages, some more formal languages. That's correct. Yes. Okay. I will.
Oh, didn't come through the microphone? No, sorry. So my question was, are these UML stereotypes? And I think you answered yes, it's based on that. And is BCL going to be derived from OCL? And you said yes, it's kind of based on that and extension.
And why do you want to use UML as a meta language specification? Why not RDF or XML or other alternatives?
Yeah, okay.
MDA.
I mean, what I just did draw is did draw the analogy between, let's say, the UML approach, which is the basis for MDA. But at the end of the day, since we are talking about services that will run on the web, we're going to use some kind of an XML schema kind of definition for this. Yeah.
Those are pretty, like, there are a lot of impedance mismatches between them, like difficult to translate between XML and DML and go back and forth, and you lose a lot of semantics between them. So I'm just curious, how did you handle that?
Yeah, sorry, there's something wrong with the noise. So the question was about the fact that you claim that there are some problems in, let's say, mapping UML into an XML schema, some inconsistency and some semantic problems, right? Yeah. So currently, what we are doing is we are defining our approach in XML schema, and internally we will probably make use of some kind of a meta model based technique. We are not grounding our work on UML in itself. So I just did only draw the analogy between UML profiles and the profiles that we want to make use of in our approach. But we're not basing it on UML in itself. It will only be XML based techniques. So the blueprint constraint language, this is, I guess, a very crucial, it's at the heart of our specification approach. It somehow looks like OCL. We think that at the end of the day, we need various languages which each have their own expressive power in order to define the constraints. We have various types of constraints, like the resource utilization constraints. We have constraints derived from SLAs, for example, and quality of service requirements. And at the same time, we think that an important
I think you've got both microphones on, that's the problem. We might need, if you're wearing a...
You wear a microphone also?
no.
I don't understand.
Make sure reflecting off your head.
Testing.
Maybe it's just me.
Somebody else is
It looks like everybody does.
Okay, so we will make use of various languages to define these constraints. And we see various categories that we're considering. We have resource utilization constraints. We have constraints which are derived from SLAs and QoS, for example. And we have an important category which, of course, focuses on security and compliance constraints. And last but not least, we also have constraints with regard to deployment, for example, and data redundancy. And what I've done on this slide is I did give a couple of examples of each type of constraints. But let's take out one, for example, the compliance constraints. And one of the constraints could be that a specific service can only be, say, deployed and used within the Netherlands because of legal, I guess, restrictions. So what we want to do at the end of the day, and we are experimenting with this, we want to formalize, of course, these rules. And what we have been doing is we have been developing a special, again, language for it, which we have called a request language, which is grounded on LTL, which is linear temporal logic. And this is a quite nice language because it will not only allow you to formalize, let's say, these rules, but it also allows you to support non-monophonic requirements. So we can relax somehow the rules and we can handle with exceptional situations. And what we have done in particular is we came up with a visual, let's say, language, which is easy to handle and understand by let's say, non-experts, non-technical experts, by people who are not very much literate in logic. And this language will allow them to express compliance rules, like the one I've just stated before. constraints, what we can do is we can make use of model checkers. So we can check whether or not a particular cloud service does meet the legal restrictions, the legal constraints. And if it wouldn't meet those legal restrictions or compliance constraints, we can also find the root cause of where the problem is and how it could be fixed. There's a lot of work behind this, and this is in fact work that we have been doing in the context of another European project, which is called Compass, and which did focus on compliance modeling, compliance constraint modeling, and compliance checking. So it goes too far in the context of this presentation to spend too much more time on it. But nevertheless, if you are interested, you could Google up Compass, written with a C, C-O-M-P-A-S, EU STRAP, and you would find a lot of publication and tools. Because I'm not only talking about specification languages here, which are conceptual, but everything is supported by tools as well, which are realized. Currently, we're in the process of further, let's say, improving the blueprinting approach. We have definitions for matching operators, to merge various blueprints, for example, to split them, to abstract parts of a blueprint, to insert new elements in blueprints, and to compose them. And we have developed various, let's say, formal and visual approaches in order to do so. So here on this slide, what I've done is I've given an example on how we can compose cloud services vertically, okay, by composing a vehicle management SAS service, which you can see at the top left-hand side, with a data storage PaaS, which you can see here at the bottom left side. So at the end of the day, what we check is we check on conformance of the PaaS with the SAS, okay, and then we blend both, let's say, services together into a composite. Okay, what I presented today is ongoing work. I think that's very clear. So most of the research results I presented are core research results in nature. Nevertheless, we do already have a blueprint definition language in place, which is, let's say, based on the requirements from industry. And currently, we're working on the support of the other phases of the blueprint lifecycle model, which I just showed to you. This will be work which will be done in the context of the forecast project, okay, in which we work together with the telco companies and some other universities within Europe. What we intend to do is we intend to focus on governance and in particular on compliance checking of cloud services with laws and legislations in order to be sure that at the end of the day, a composite, a cloud service composite, does meet legal requirements or regulatory compliance requirements. Within forecast, we are also working on standardization. I mean, this is, of course, the basis for any interoperability. And what we want to do, what we plan to do, is we plan together with industry to come up with standards for example, blueprint definition and blueprint composition. Last but not least, since we are working in an R&D project, we are working bottom-up, which means that we are starting from a platform. In this case, we have started from a platform provided by Sony Ericsson for composing cloud services, and we are extending this platform in order to support the blueprinting approach. So I tried to be in time, so I had to rush through a couple of slides. Nevertheless, I hope that the basic idea is clear to you of what we try to do. So I try to explain to you the problems, the impediments of existing SAS solutions. I try to explain to you that they are quite monolithic in nature and it's very hard to customize them and extend them and compose them into end-to-end applications. And what I did do next is I introduced to you this multi-channel syndicated approach, which will allow you to compose various SAS solutions into an end-to-end process, which is realized as a business process as a service, where each and every SAS component can find the best matching lower level cloud services, meaning the best fitting PaaS components or IaaS components. I guess that's the basic idea. I introduced to you the blueprinting approach and also the basic constituents of the approach. And I try to give you insight in the kitchen of the things we are developing right now. So thank you very much for your attention. If there are questions, the floor is open.
Modify the components underneath, or I'm not sure how this is working. Like, for example, when you say you're going to partition horizontally and vertically, how are you going to partition it? Because they're not going to be.
Okay, what we assume there that there is a willingness at the side of SAS vendors, for example, to describe at least the requirements that functionality at the SAS level has with regards to underlying cloud services, meaning PaaS services. Meaning PaaS service requirements and IaaS service requirements. Okay, so what we assume is that they will use the blueprint definition language. Okay, they will describe functionality at the SAS level, so provided functionality, but also required functionality at the level of the PaaS and IaaS. This is our core assumption here. They would provide the client more flexibility. And there's a need at the side of the clients to find indeed better fitting solutions in some cases, that better fit their needs. Yeah. I mean, this is not something that we just came up with ourselves. I mean, also the telco providers, for example, let's say back up this observation. Yeah, that's of course, I'm an academic, so this is more like looking into a crystal ball. I mean, from an EU perspective, we think that this research is valid in the sense that there is a need from companies to come up with solutions in this space. It's very hard for me to let's say extrapolate that to other companies. I cannot do that. Yes, of course. So with regard to compliance checking, this is not an easy thing by all means, and especially not if you want to, I guess, assure compliance at all levels of the cloud stack. For example, detection of compliance problems is not that easy at all. What we can, for example, formalize in terms of compliance constraints is only the tip of the iceberg. There's a lot of things which we cannot capture. So it's very hard then also to detect problems. So we need more powerful, more expressive languages, for example, to express compliance requirements, and also more powerful approaches to detect where potential problems are. In terms of composition, this is also not very much straightforward. I've not touched upon semantic interoperability issues, but obviously this is also this is a large problem. Having said that, what in case that two cloud services do match roughly, but not exactly? How do we build, for example, adapters? Things like that. So there's a lot of, I guess, interoperability problems beneath the surface that need to be solved before this blueprinting approach can become a reality. Another issue is management, evolution of the BPaaS services. So how to deal with changes. What if suddenly an IaaS provider decides to change its QoS? How do you detect it? How do you monitor it? How do you replace maybe an IaaS vendor? So there's a lot of issues there. Mm-hmm. Yes. Yes, so the question here was about who will be responsible from a legal point of view in case that you guarantee compliance, but at the end of the day, this is not met. Of course, this is a legal question rather than a technical question. So that's for me very hard to answer. Having said that, I mean, from a security perspective, it does matter. So it is an important issue, like other issues as well, like trust. But yeah, we cannot solve it all in an EU project, so we had to make some assumptions there. Yeah, so the question is about compliance. So what if you find out that your SAS solution, for example, is only partially compliant? So how can you make it fit? Yeah, this is indeed a very interesting research question. And by all means, the compliance checking challenge is not easy. It's all right. We have already been working on the problem for 4 years together with companies like PricewaterhouseCoopers. And we did come up with some, let's say, initial solutions. But the entire problem is far from being resolved right now. So there's still a lot of challenges on the way. But there is some hope, yes, definitely. Yeah, yeah, thank you. Yes, you can find it at the website.